Hi everybody. So in today's video, I'm going to be coding a correlation matrix, testing the significance of each correlation, and constructing a cointegration matrix to test and see whether any of these ETFs here have some statistical arbitrage between them. So I'm going to load my libraries now. So import, spelled that wrong. Import numpy as np, import pandas as pd. From stats models dot tsa dot stat is it tools import ad fuller. So this is the augmented Dickey Fuller test, and it's going to test and see whether there's any co-integration between a pair of these ETFs here. So now I'm also going to import requests and import JSON, and this should be good to go. So I have a function up here, stock data, returns me a URL, and like I have to use an API key for it. The data set that I'm using is from Financial Modeling Prep, so you can get your own free API key and run this yourself if you'd like to. So let's see, I'm going to create an array called close, and it's an empty list, and then I'm going to do for tick in. It's called ETF underscore tickers, so ETF tickers. Okay, I don't know why that happened. Let me just come back here. Okay, so I will do, so I'll do address equals stock data of tick, and then response equals, I'm going to create a session so it'll place faster requests. So session equals requests dot session. So this will be session.get address .json, and then I will do stock prices equals response, no, pd.data frame of response historical, and then this will be adjusted close values reversed because the newest stock price is first and I don't want that. So reverse that to list, and I'm going to do close append stock prices, and then here I'm going to do close equals numpy array of close transpose. So we're going to print close. So I'll come over here and do python 3 coint.py. Maybe I can move this up here. It always takes a little minute just on like the first imports because I just booted up the terminal. Let me add more space here by closing this out. Okay, there's a little error. I'm going to print response. Reset that. Okay, so this is weird. Should have. It ran. Okay, let me do response.keys. So reset coin historical. Did I misspell this? Oh, this is why. Yeah, my mistake. My mistake. So I will just come back here and do, so I'll reset this python 3 coint.py. Why is this still doing an error? So I'm going to print tick, and wherever it's not loading, I'm just going to get rid of that. Fig IAU. What's going on here? Oh, another comma error. Okay. So I think this pretty much works now. So I'm sorry, I apologize for these errors. It's just like it comes with coding. So Python 3 coint.py. Okay, perfect. So we have our data loaded. So now I will do a rate of return. So ROR equals close. Since we reversed it, it's going to be 1, and then close -1 minus 1.0. Okay, good. So the next step for this is to calculate the correlation matrix. So correlation of x, so it's going to be m and n equals x dot shape. Yeah, so ROR is going to be put into this, so it's going to be correlation of ROR, and then mu is going to be 1 divided by m times numpy dot 1s of m dot dot x. Covariance is going to be 1 divided by m minus 1 times x minus mu dot transpose dot dot x minus mu, and now we need the correlations, so it's going to be SD equals covariance, no, numpy dot square root numpy dot diagonal covariance, and then this will be numpy array of I for I in this. So this will be correlation is going to be covariance divided by standard deviation dot dot standard deviation dot transpose, and I'm going to print this out. So correlation. So I'll come here and I'll do Python 3 coint.py. Let me make this a little bit bigger. Okay, perfect. Yeah, we have the correlation matrix. It's pretty big. We have like a good, I think 14. So 3, 6, 9, 11, 13, 15. Does that have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15? Yep, 15 assets. So ETF. So now that we have that, I think I could do the. Okay, yeah, we could test the significance of each correlation. So it'll be for I in range n, for j in range n. If I equals j, correlation of I, j will equal just an empty bar. Else, it'll be t stat equals, so that'll be correlation of I of j times numpy dot square root of, is it the, oh yeah, the sample size, so that'll be m minus 2 divided by the square root of 1.0 minus correl I of j squared. So yeah, I forgot I gotta put a parenthesis here. Okay, so now I'm gonna do from scipy.stats import norm. So I'm gonna calculate all the test statistics p-values. So it'll be p-value equals norm dot, no, 1.0 minus norm dot CDF of the absolute value of t stat. I forgot the U here, so p-value. So I will do, let's see, so I'll do a 5% alpha and I'll do a 1% alpha. So 5% is going to have two asterisks and 1% is going to have one asterisk. So I will do, okay, so if p-value is less than or equal to 0.01, asterisk is going to be two of these. L if p value is less than or equal to 0.05, asterisk is going to be 1 star, else asterisk equals empty string. So now what I'm going to do is coral of I, j equals str round coral I, j to the fourth plus asterisk. And then down here, I'm going to return numpy.array of coral. So now I'll call this core, and it'll be print core. So let me do reset on this Python 3 coint.py. No errors, please. Could not convert string to float. Oh, that's right. I have to do coral equals coral.toList because you can't put a string in a numpy array. So I'm going to do reset. Okay, so we've got some significant correlations here. So yeah, it bleeps out the middle. Some of these are not as significant. Hang on. Let me figure out how to display full pandas table. Okay, so I believe it's going to be pd dot set option. Yeah, pd dot set option. Let me just put this here. Display dot max call with none, and pd dot set option of display dot width none. Okay, so I believe I have that set. So now actually I'm gonna make the tickers for this. So they're up here, which is good. So I could do pd.data frame of coral and index equals ETF tickers and columns equals ETF tickers. So I'll redo this. So Python 3 coint.py. Okay, this is a lot. Let's see. Okay, yeah, not all of them are significant. But what we could do, I think I'll lower this list. So, because a lot of these are just like, I don't need S&P 500 ETF. Dividend, 20-year Treasury bond. I don't need that. I'll get rid of volatility index too. So this is 3, 6, 9, 10. 3, 6, 9, 10. Okay. Yeah, I'll keep it like this. So I'm just going to open a new terminal and do Python 3 coint.py. Okay, perfect. So we have our correlation matrix with all the significant variables. So now let's get right to cointegration. So I will come up here and do def cointegration, and it takes x and y, So now what I'm going to do is actually, instead of calling it cointegration, I'm going to call it residuals. So the covariance is going to equal numpy.sum for I. Wait, I need the mean for the x, so it's going to be mu x equals numpy.mean x and mu y equals numpy.mean y. So for I in x, it'll be I minus, oh wait, this is supposed to be squared. No. Actually, I'm confusing myself. It's going to be ij in zip x, y. So this will be I minus mu of x times j minus mu of y. And then the variance is going to be numpy.sum for I in x. It'll just be the power of I minus mu of x squared. And then the beta will be covariance divided by variance. And their denominators cancel out, so that's why I didn't include them. So now alpha will be mu of y minus beta times mu of x. And now that we have that, we could do, let's see, how would I, okay, the close prices. So, okay, correlation is good, but I need to do RORT, no, close T equals close.transpose. Yeah, because for co-integration, we have to pass, like, the actual prices. So I will come here and do, for I in range, or actually, I should have just done this here. So n equals length of ETF tickers. So for I in range n, so I'm going to call this matrix equals empty list, and then I'm going to come here and do temp equals empty list, and for j in range n, residuals equals residuals of close T of I and close T of j. If I equals j, we will do temp.append, the same hyphen, else we'll work on this, so it's going to be result of AD Fuller of residuals, and then it's going to be p-value equals result of 1, and then we have two alphas. I guess I could do the same thing with the asterisk variable. Yeah, so I'm going to come here and do the same thing. If p-value is less than 1, else if it's whatever. So let me just bring this here. Okay, good. No errors on that. So it'll be temp.append. Well, okay, if asterisk equals empty, we will do temp.append no. Else, we will do temp.append yes plus asterisk. So we have temporary, so now we need to fill matrix. Not in this one. Matrix.append temp. And then once we have that, we could do coint equals pd.data frame matrix index equals ETF tickers, and columns equals ETF tickers. So print coint. So we're still printing correlation. Okay, so I will add a line here just to break it. So up top, I'm going to do print correlation matrix, and then down here, I'm going to do print cointegration matrix. Okay, so I'm going to reset this. I'm going to bring this up here and do Python 3 coint.py. So now if this works, we can check to see which pairs that we want to have statarb with. We're not going to do the statarb in this video, but sample size is too short to use in selected regression component. Let me print residuals. So co-integrate that. Wow, I misspelled print. I just came back from school having a little brain fart right here, but reset that. Oh wow, you know what the fucking error was? It doesn't. Wait, where'd it go? That's correlation. It never returned anything. Oh my god. Okay, so I'm gonna do return alpha plus, or rather, I could do y minus alpha plus beta times x. So yeah, this will give the residuals for this. So yeah, now let me run this again. I'm sure it works. Let me actually even make this terminal bigger. So Python 3 coint.py. Come on, work, work, work. Okay, so now that we have it set, we can see that there's only two co-integrated pairs that can be traded, and that's between VIG and DBA. So VIG and DBA are co-integrated. So let's look and see the correlation matrix of these. VIG and DBA have a positive correlation of 0.1927, and they're significant at a 1% alpha, but they're not co-integrated. So generally, this fails the statistical arbitrage test because it's good to have a statistically significant correlation, but this correlation is not even that high. So yeah, I guess we'll have to just ignore that. Let me bring back some of. Maybe I should bring back some more tickers, or add some. I could do BlackRock, Tesla, NVIDIA, or no, rather Microsoft instead of Tesla, NVIDIA, and I'll just stick to those three. So yeah, let me reset this, and then Python 3 coint.py. Pull this up again. Okay, so we got the correlation matrix. Okay, so now we can see there's actually a statistically significant co-integration to the 1% alpha between NVIDIA and IAU, but the rest of them are none. Yeah, NVIDIA and IAU, so that'll be... Okay, so NVIDIA is co-integrated with IAU, but IAU is not co-integrated with NVIDIA, so this may fail the test, but if it's on one side, so This would mean that the NVIDIA is being approximated and IAU is fixed. So yeah, on this side. Okay, so let's check their correlation now. So NVIDIA and IAU. So IAU, NVIDIA. Okay, they do not have a significant correlation. Let's do IAU to NVIDIA. Oh no. Yeah, they don't have a significant correlation and they're not really moving with each other. So yeah, as of this, I would say that like these aren't you can't really stat arb these pairs because like both should agree with it. But yeah, that's all I wanted to share with today. I'm going to do some research into figuring out which stocks and ETFs are co-integrated and correlated. So maybe then we can run a stat arb model. But for now, I'll just leave it at this. I hope y'all enjoyed watching my video. I'm going to keep coming out with more, so stay tuned. Peace out.